While there are many clean energy technologies available today, there are none with the power and scope to fully replace fossil fuels. Developing an energy plan for the future that is both sustainable and feasible continues to be one of the biggest challenges of the coming century. In the following slides, we will explore some cutting-edge technologies that may help overcome this challenge. As high school chemistry students, you may be wondering how what you're learning can apply to the real world. Chemistry is considered to be the central science and is important in both the fields of energy and climate science. It is important for people to be able to apply quantitative principles in chemistry and energy science to understand the current problems and evaluate their impact. Inevitably, the person who must solve the climate crisis will be from your generation. The solar reflective tower is a new take on the idea of solar power. The tower operates via a system of mirrors that concentrate reflected sunlight. This light energy heats water to produce steam, which travels down the column of the tower, powering a steam turbine to produce electricity. This is a solar updraft tower. As a relatively new technology, there are only a handful of these in existence. Solar updraft towers, also called buoyancy towers, work in the same way as a hot air balloon. There is a greenhouse-like canopy surrounding the base of the tower. Sunlight passes through this canopy and heats the air underneath. This hot air travels upward through the base of the tower, generating winds up to 30 knots. Ready to catch the winds, several wind turbines are positioned at the base of the tower. A perk of the updraft towers is that they will continue to produce energy even at night, as the grounds give up its stored energy and the ambient air decreases in temperature. A projected tower in Arizona is supposed to be 2,600 feet tall, making it one of the tallest man-made structures. You could even say it's taking solar energy to new heights. The yearly output from the Ivanpah solar facility in the Mojave Desert is 420 gigawatt hours. This is equal to the energy produced in an hour by a 420 gigawatt source. The projected output for the solar updraft tower being built in Arizona is 876 gigawatt hours per year. Using these numbers, we can calculate how much CO2 emissions can be saved over the course of 1 year. Natural gas is composed mainly of methane. From its heat of combustion, we can calculate the energy density of methane via its molar mass. Because there is a one-to-one stoichiometric conversion between methane and CO2, there is a direct conversion between the energy density of natural gas and the equivalent energy content per kilogram of CO2. Using the figure calculated in the previous slide, we can go on to calculate the tonnage of carbon dioxide that will be saved by the Ivanpah solar tower in a year. We begin with the energy production from the solar plant and use the energy density to convert this energy value to a mass of carbon dioxide. After factoring in the efficiency of natural gas power plants, we find that 184,000 tons of carbon dioxide emissions are saved per year. Scaling this figure up to the projected solar updraft tower, we find that it will save 383,000 tons of CO2 emissions. This is nearly 40 cowboy stadiums of pure CO2 gas at standard temperature and pressure conditions. By a similar calculation, starting with the energy density of coal, we can find the comparable energy density of CO2. Using that figure, we can go on to calculate the tonnage of CO2 emissions that will be saved per year. After factoring in the efficiency of coal power plants, we find that for the reflective tower, 341,000 tons of CO2 emissions from coal could be saved. For the solar updraft tower, this figure is 711,000 tons of CO2 emissions. These reductions are small but not insignificant. With greater understanding and investment, renewable energy technologies such as these will pave the way for a more sustainable future.